All right. Good morning, good afternoon, good evening, wherever you are. I am Nick Chase from Mirantis, and welcome to today's webinar. Today we are talking about YAML. We are going to be talking about YAML, and we're going to be talking about Kubernetes objects. The extent to which we do either, we're going to talk about in just a minute. Let me just tell you who I am. I am Nick Chase. I handle technical content here at Mirantis. I've also been a programmer and a writer and all kinds of things. So let's just take care of a little bit of housekeeping real quick. You'll notice that there is a place to submit questions on the side panel. Please go ahead and feel free to do that throughout the webinar whenever you have any questions. We're going to collect them all up for the end. In all likelihood, but don't feel like you have to wait for the end for that. All right, so at the end of the webinar, we're going to give you a link where you can get these slides and also a recording. Now, before we do anything else, what I would really like to do is go ahead and just get a feel for where you are in terms of familiarity with Kubernetes, with the Kubernetes objects themselves. And the reason for that is I don't want to kind of overwhelm you with a bunch of information that you already have. And at the same time, I don't want to kind of leave you in the dust if you have no idea what these objects are. So it looks like we're trending towards slightly to moderately familiar. So if you have a general idea of how these objects work, that is great. And that's probably exactly where I've targeted this to. If you're very familiar, I will ask you please just kind of bear with us. And if you're not familiar at all with the Kubernetes objects, I will try to give you some context. But this, the things that we're going to say about YAML itself apply to all YAML, not just YAML as used by Kubernetes. So you'll still get something out of this regardless. All right, let's give it another 10 seconds, and then we'll close the poll. Okay, and all right. So, so in general, it seems like you all have a general idea. Whoa, that's the wrong screen. I have lost my presentation. Let's go back and get it. There we are. Okay. Right. Okay, there we are. Now, so we're going to go through and we're going to talk about YAML. As I said, I'm kind of assuming that you have a general idea of how Kubernetes works, and that seems to be the case. But again, basically, we are going to be talking about YAML itself using Kubernetes as the example. So, all right. So let's kind of move on and look at how we're going to approach this. We're going to start out by talking about the overall structure of YAML documents and how they work using the workload related objects. So things like, pods and deployments and things like that, things that you're probably very familiar with. Then we're going to talk about data types, which a lot of people don't even realize YAML has. And we're going to do that in the context of configuration related objects like config maps. And then we're going to handle some things that can look really confusing if you're not familiar with them, which are repeated nodes. Sometimes this tends to stump people who are new to YAML because YAML itself is pretty simple, and then you hit these you hit these annotations in there and you're thinking, what the heck is this? So we're going to hit that in the context of services related objects. And then the putting it together section is pretty much just more objects that we haven't covered in other places, but since most of you are fairly familiar with them, we'll probably just kind of go through that fairly quickly. All right, so let us start out with the overall structure of YAML. Now, YAML is stands for, depending on what year it is, it either stands for yet another markup language or YAML ain't markup language. Take your pick, doesn't matter. It's not abbreviated in that there is no periods in there. That is what is known as an initialism, I have found out. All right, so moving straight in. If you look, this first section here is a very, very simple YAML document that defines a container. So let's look at some of the components of that. We have the fact that you've got a key such as name or image, and then a colon and a space. That space is very important to indicate that we're moving on to the next thing, which would be the value. Okay, so key, colon, space, value, and you can have multiples of those on individual lines. And comments, as you're probably familiar with from other languages, we can denote those with a pound sign. Now, again, this is a very, very, very simple YAML document. And but what's interesting here is that YAML is what's called a superset of JSON. Now, what does that mean? That means that if it's a valid JSON document, it is a valid YAML document. Now, not necessarily the other way around, but what that means is if we were going to do this in JSON, this looks familiar. This is, you're used to this. You've got, your brackets for the object. We've got the key, the value, a comma to separate them in this case. And of course, these all have to be strings for JSON. Now, so that is actually valid YAML as well. And we'll see later that sometimes you kind of mix up, the two. So, all right, so now this is a container, as I said, but you will never specify a container by itself in Kubernetes. Now, these YAML files are used typically when you want to create an object or edit an object. You'll do kube control create -f and then the file, or you'll specifically send in the YAML. But as I said, you will never create a container by itself. A container will always be part of a pod, okay, or some other object, but at least a pod. So, for example, we have some additional, a little bit more complicated YAML structure here. So here we have a pod. Some things that are sort of standard for Kubernetes objects. Typically, you'll have the API version, the kind, which is what says what this thing is. In this case, it's a pod. The metadata, which at the very least has to have the name. Okay. On the back end, it is required to have the name, the namespace, and the ID. But the namespace has the default value of default. You can change that if you want. And the ID is usually assigned to it by Kubernetes itself, so you don't have to indicate that yourself. Other things that you can put in are, labels or when it's created and so on. So in this case, we're adding a couple of labels. We're going to talk about this YAML format in a minute, and then the spec, which would be the information about it. So we've got the spec. We're specifying we have multiple containers And then you'll notice here on the bottom, this last one, this is exactly the simple container document that we had before. So we have a name, we have an image. It's a different name, a different image, but that's okay. We can also specify other information for containers. So let's look at the new things about this YAML document that we didn't see before. First off, you'll notice that we have some indentations. Okay, so name is indented by, oops, what did I just do? No, there we go. Name is indented by a couple of spaces here. This is like Python or any of your other indentation managed languages. So we know that name and labels are one level underneath metadata. Same here, containers is one level underneath spec. All right, so those indentations are really, really important. And if you mess them up, it's not going to compile, or you're not going to get what you think you're going to get. All right, now, another structure that we can look at here is the sequence. Okay, so for example, this pod has multiple labels. Okay, in this case, we have the app label and the status label, and those sequence items are denoted by this dash. Okay, now you notice we have the same thing under containers. The containers, there are multiple items under the containers as referenced by these dashes. So the first one has the name, the image, the command, and the arguments. The second one, we get to this dash, we know we're in a new object now. We have just the name and image. All right, now, but what about this weird thing here with these brackets? Well, if you think back to what we were saying on JSON, that all JSON structures are legal YAML structures. Well, this would be a sequence in JSON. So doing that would be the same as having the arguments as sequence items underneath those keys. Okay. Now, all right. So let's kind of move on. So that's the basic structure. Typically, you're not going to run a pod by itself. It'll usually be part of a replica set. Again, you guys are pretty familiar with Kubernetes objects, so I just want to sort of point out how things fit together. I'm not going to go into detail about exactly which keys go into which objects. Replication controller, you'll notice a replication controller and the replica set are virtually identical, except for the kind and the API version, and of course the name, but the name is arbitrary. So, okay. All right. So a deployment is similar to a replica set, but in that, we specify, okay, this is how many replicas we want, and this is what those replicas are. The template specifies we have the metadata and the spec. So basically, we've got a pod down here under template, a template pod. We're specifying how many of them. And deployments are convenient because they make it easy to expose your application, because you create your deployment and then you can just expose it, and Kubernetes goes ahead and creates a service for you, and it exposes it. Hence the word expose, oddly enough. Okay. So you can also have multiple, it says here multiple objects in a document, but really what it should say is multiple documents in a file, because each of these objects is considered a YAML document. So for example, here we have a service, a complete service starting, from so we've got the API version, kind, metadata, and spec, which are the things that we said that these objects should have. And then you notice down here, we're into another object. So this is a second document. So in this case, we actually have 3 documents. We've got our service, and then this, this 3 dashes here, that indicates a new document. All right, so we've got our 3 dashes, and we come in, we have a stateful set, which you may be familiar with. That is where you actually keep your information persistent. And then at the end of this stateful set, we have 3 dots, which indicates the end of the document. And then after that, we've got 3 dashes to start up a new one. Now, these 3 dots are completely optional in most cases. When you have a file and you're sending that file to Kubernetes, it knows that you've ended the last one when you start the next one. But if you are streaming data to Kubernetes, that 3 dots there is useful because it tells Kubernetes, okay, go ahead and do this one. And then maybe you're keeping the connection open for the next one, but Kubernetes is not still waiting for more information. Okay. So, daemon sets. Let's take a look here at some other YAML structures. We've got a basic. We've got our API version, our kind, metadata, and spec as usual. All right. Now, like a deployment, the template is basically your pod. So we've got more metadata, labels, spec, etc. These are the containers that are run. Now, all of this is exactly the types of things that we've seen before. Obviously, containers, I've just put it over here because it's too long. We've got our dictionary, so our key. Whoops. We've got our key and our values. We've got our sequences as indicated by these dashes. But also, if you come down to the bottom here, what you'll see is this greater than symbol. So the arguments for the command are going to be -c, and then the actual script is going to be this while true, do, etc., etc. And this greater than sign basically says everything after this until the next item is a single scalar text value. And because we are not, because we're using the greater than sign, we don't care about preserving line breaks. So this is another function that you need to know about. So daemon sets, of course, run one copy on every node when the node comes up. So this is essentially telling every node to run a script that every 10 seconds says that the daemon set's running. Obviously, it's just a toy function, but you get the idea of how that works. Now, let's see where we go from here. So cron job. So in the daemon set, we talked about having scalar text that does not worry about preserving line breaks. But sometimes you do want to worry about preserving the line breaks, and you can do that with a slightly different slightly different form. So here's a cron job. This probably looks familiar. You know, you've got your schedule, and then the job template is what you want it to do every, you know, 5, whatever. You want it to, in this case, we want it to pull up a container. We've got the bash image. We're sending it a command. Whoops. And because we're using the pipe symbol says, yes, this is a text scalar, but we do want to preserve the line breaks in this. So this would be hello world, \n. It's good to see you. All right. And then just, it doesn't have to be a cron job. It could just be a regular job. So we've got our job object. And here you see another example of multiple commands in a sequence. Again, these could have been written as independent items with dashes underneath args, but this is, because you've got these dashes here, this is probably a better way to do it because it's a little less confusing. All right, now let's see here. I have lost my window. There we are. Oh, that's the wrong one. Oh, come on. Give me a moment to orient myself, everyone. I apologize. There we go. I lost my window. Here we go. Now, do we have any particular questions regarding this section that we've already covered? If you do, throw them in here now. Just take like 10 seconds so that if there's something that's really nagging, I can address it as we go on. Okay, so yeah, we do have a question here in the context of the YAML structure. Can we write labels as, say, labels and then the JSON version of the sequence? You know, so bracket, you know, app nginx, comma, type, web server. Yes, you can, but don't forget the comma, because the person who asked the question, Shabir, you left out the comma, so you got to make sure you get that in there. All right. And also you need to make sure that you quote those names and values as strings. Otherwise, they won't work for the JSON parser. So we have a question, why do you have to give the image name? If the container is up, can we just specify the name? Well, remember that these documents are typically used to specify what you want to create. Now, if you are just editing an existing object, I believe you can leave that stuff out. But we'd have to try that out. And if we have time, we can try those things out. All right, let us move on to the next section. All right, so let's talk about data types. Now, one thing that can be useful when you are configuring your pods and your containers and so on is the use of a config map. Now, a config map can be used to specify values that you ultimately want to wind up as environment variables in your container. So it's easy to specify a config map. As you can see here, you know, kind config map, same as before. We've got our metadata, and then the data is literally just keys and values. So in this case, you know, how special is it? It's very special. You know, what's the weight? You know, we've got data for a picture. Again, notice we're using the pipe to preserve line spaces, line breaks, which probably is not a good idea for this data, but that's beside the point. All right, now, these are very specific types that we have here. So you'll notice that I've added a few pieces of information. So where we had just data before, now we've got 2 exclamation points and map, because data is a map. That is the kind of data type it is. At the same time, vary and wait are strings. So we're specifying them as strings. And the picture, we want this to be treated as binary data. So we are labeling that as binary. Now, there are a lot of types that are defined in YAML itself, such as floating point variables and all kinds of things. And those you would think would be useful for something like config maps or other values that we need to work with. However, there's a couple things to take note of. One, not every parser supports every data type. So while YAML may specify all these things, that doesn't mean they're actually available. And in fact, Kubernetes has a fairly limited set of these that it works well with. You know, it is happy with string, it's happy with map, it's happy with binary, it's happy with one more that we're going to talk about in a minute. Not so happy with things like float. So just kind of keep that in mind when you are building your documents, that not every parser supports every type. Okay, so another type that we can use that Kubernetes is happy with is base 64. Now, you'll notice here I've got a secret put in here. And this is data that you don't necessarily want to be included directly in your configurations because, well, it's supposed to be secret. You don't want it in any log files. You just want it to be available so that you can call it from a pod. And that's great. But when you put it in using data, the data field, it needs to be encoded as base 64. Now, I've noted here that these are base 64 values. However, it's really not necessary because YAML parsers typically are going to auto-detect the types. Okay, so they can pretty much tell what's a string, what's a base 64. So if you have a improperly formatted base 64 value, for example, if you have a value that comes from a date that goes into your configuration file, there used to be a bug in Kubernetes, it's not there anymore, that when that got converted to base 64, it still had a dash in it, and that would break the parser. But now those values are automatically quoted, which solves that problem. So, all right. So let's look at, these are the built-in data types. As I said, there are a bunch of them that are technically built in for YAML. String, map, int, float, etc., Boolean. The ones that I've starred here, string, map, base 64, binary, these are ones that I know work well with the Kubernetes parser. I can't vouch for the other ones. Can I say for sure they do not work? No, I cannot, although I've had trouble with most of them. But I can't say for sure that they do work. So your mileage may vary. You can also create your own types, but that is typically not something you're going to do in Kubernetes, but it is possible in YAML. All right, now let me take a quick look here. Can we just use JSON notation for creating Kubernetes objects and not YAML? Yeah, you sure could. You sure could. And Mr. Fishman, no, I'm not. So, okay. So, all right, moving on. Repeated nodes. So this is something that confused the heck out of me when I first started with YAML, because I'd be going along going, well, this is really easy. You just got your lists and your directory, your dictionaries, and everything's fine. There's nothing complicated about this YAML at all. And I was looking at files like this one. So we have here a service. So like a service, we're specifying the ports, and we're naming it. This is a simple service that doesn't reach to the outside. This is a more complicated service. Well, I'm sorry, this is the same service. You'll notice here that we are using port 80. In this case, this is a more complicated service. I'm sorry, it's not the same one. But this is a situation where we want to use port 80 as both the port and the target port. So here I am just bopping along. Oh, I understand everything. This is cool. And I run into something like this. What is going on here? Okay, so what is going on here is when you see this ampersand and then a value, that is creating an anchor basically that you can then reference later. So here we're creating a variable called open port, giving it a value of 80, and then we can reference it anywhere in the document that we want. Notice I said anywhere in the document. When I say document, I mean this object. If you have a file that has multiple documents, unfortunately, these anchors do not go between documents. So it's annoying, but just kind of keep it in mind. Another service-related thing would be endpoints. So when you create a service, you have then endpoints that can be reached by that service. So here you have multiple subsets. Again, look for the dashes to tell you where these new items begin. So addresses, they have an IP address, and then they have ports, and these ports are pretty standard. You notice here the same thing: my port, port 1, protocol 2, TCP. So what's nice is we can then also use these anchors to create a complex value. So in this case, standard port is name, port, protocol. So once we define that, we can then go ahead and use it throughout the document. So we've got our addresses, the IP address, and then the ports. So we can just say standard port, standard port. We can have as many of those as we want. Another services related item would be Ingress. So another example here is we've got our rules for the Ingress. For HTTP, we've got our path and the backend for that path. So I think my indentation is screwy here. I apologize. These are supposed to be indented a bit more. But the important thing here is we are specifying that a standard backend would be a service name and a service port, and then we are putting them into these, we're referencing it here. Now, here's one important thing. Let's see if I didn't do that. Yes, I did. Okay. Now, here is one important thing to recognize. You would think, and the YAML specification says that what you can do is actually replace a specific variable. So here we're creating the anchor with these two values, service name and service port, and we're making use of it down here, and we can replace the service port but leave the service name, theoretically. Note that this does not work. I don't know if this is a bug or a feature, but it does not work. Just keep that in mind. Okay. All right. So let me see if we have any basic questions from here. Hold on. Somebody says, not a question, but looks like C pointers. Yeah, it does look like C pointers, actually. Yeah, I can't dispute that. All right, we'll go through the rest of the questions. So from here, we've covered most of the YAML, and I'm just going to review a couple of the other. I'm going to review a couple of the other objects so that we can just kind of get a feel for what else is out there. There is one person who asked the question, what are all of the possible values for the kind? So, it's pods and deployments and all that. And we've covered a lot of them so far, and I'm going to show you most of the rest of them in this section. So I can't guarantee we're going to hit everything, but we're going to hit most of them. All right, so other objects you might encounter. Storage class is mostly set up by operators. It is necessary in order for you to have storage. Obviously, you need to have a storage class to reference. Volumes are not typically created independently, but they are typically created as part of your pod definition or other template definition. So you'll see here volumes, name of the volume, and then specific information that has to do with that volume type. You'll notice here there are a ton of different types. Okay, I think I counted. I forget how many I counted. I think there's like 26 different types, something like that. And some of them are more common than others. For example, empty directory is literally going to just create an empty directory on the node for you to use. Local is referring to a specific directory on that local node. You have other things like NFS for network file system. One that's really interesting and that I highly recommend checking out is Downward API. Downward API isn't really a volume in the sense that you're probably used to it, but it's a way to pass information into the container. So it's beyond the scope of what we're doing right now, but I highly recommend that you take a look at that. We talked a little bit about config map, and you're basically going to reference the config map and then the key within the config map. So you create the config map and then you reference it within the volume. Now, same thing for secrets. Some of these things are sort of vendor related. For example, you see here vSphere volume. These are things that vendors have decided that they want to make their storage solution available within Kubernetes. And so they've created the code necessary for that and made it available. And, there's nothing wrong with that. That's exactly what these things, it's exactly how Kubernetes was architected in order to make that possible. All right. So in order for you to use it, you need to claim a certain amount of space. So in this case, we're saying we want 2 gigs. And then that gets turned into a claim on on an actual volume. So here we're creating a volume, in this case 5 gigs. There's a lot to sort of unpack here, again, beyond the scope of what we're doing today, but I encourage you to take a look at the documentation for persistent volume and take a look at all of the different things that you can set and how they work, and so on. For a technology that is based on essentially being stateless, there's a lot to do with volumes, which is good because the world is not stateless. So namespaces. You're not usually going to create a namespace using YAML. Typically, you're just going to say, kube control create namespace, blah. But if you are using infrastructure as code, and I highly recommend that you do, then you are going to be specifying just about everything as YAML. So it's good to know how to create one, and this is it. It's pretty simple. It's almost as simple as a container. Roles now. So security is a huge topic, of course. Obviously, there is no way we're going to hit everything about security in this conversation, but in terms of access control, Kubernetes uses what's called RBAC, so role-based access control. And what that means is you create roles and decide what those roles relate to. So in this case, this is a role that has to do with pods. It lets you get, watch, and list them. And then you assign users to those roles using a role binding. Okay, so we've got a role binding, we've got our user, and then we're referencing that role that we just created a minute ago. So we created the pod reader role, and now we're binding it to this user. Okay. There are also cluster roles. So while a role is typically limited to a namespace, as you can see here, namespace, cluster roles are not. They refer to the whole cluster. And then, of course, same thing, you can then bind a cluster role. So now you can then bind a cluster role to a group of users, which is kind of like a role. So you say, all right, if you're an admin, you can do this, that, the other thing. All right. And finally, one of our more complicated objects here, again, not going to go into the details, but we see here you can get fairly complicated with these objects. So a network policy, and this doesn't even have all of the information that you could have. So we've got a network policy, we've got our metadata, and then the spec is selecting specific pods that this refers to. And then this network policy has ingress and egress types. So we can talk about the egress type first. It says where connections can go, and the ports and protocols that those connections can use. Ingress is, of course, incoming connections. So where can these connections come from, and where can they connect to once they come in?